All right, so today we're going to be looking at expressions that have negative exponents and what the rules are. Okay, so we've learned the rules with multiplying bases, same bases with exponents, dividing same bases with exponents, and then also a base with an exponent raised to an exponent. So this is just circumstantial. If you happen to have a negative exponent, what are you going to do with it? Okay, so let's start out by let's say we want to solve this, or I'm sorry, simplify this, c squared over c to the fifth. We're going to do it two different ways. Okay, so the rule, right? The rule is when you are dividing the same base with exponents, you keep the base and then you subtract the exponents, right? So I end up with c to the negative 3 because 2 minus 5 is negative 3. Okay, all right, so I get c to the negative 3. Well, what would we do with that negative? Well, let's say we expanded it out. Let's say we did it a different way. Let's say we had 2 c's on top and 5 c's on the bottom. This is the expanded form. Okay, I can go ahead and reduce one on top with one on the bottom, another one on top with one on the bottom, and I end up with 3 c's, but these are on the bottom. These are on the denominator. So really, since there's nothing up here, I can put a 1, and I get 1 over c times c times c, which is really 1 over c cubed. So these are the same. These are the same. They should be the same. So that means that this c to the negative 3, if I want a positive exponent, I need to actually bring it to the bottom. Okay? So they need to be the same. So the rule is to go from here to here. So if we get a negative exponent, we need to actually change its position, and then that makes the exponent positive once you change the position. Okay? So here's the key concept. Okay, there's a lot of stuff here. So if basically what it's saying is, if you have a negative exponent, you're going to take the reciprocal. Okay, so let's look at an example. So if we have a to the negative n, well, that's going to be 1 over a to the positive n. So to take care of that negative. Now, what a lot of students do is they think this negative goes in front and goes down to the base. That negative is never going to make this base negative. All it does is just change its position, changes its level. It's on top, right? The base is on top. Now it's on the bottom, and now my exponent is positive. Okay, so let's say we have 2 to the negative 4. All right. So do not say that that's a negative 2. That's not true. That negative is going to reciprocate, bring the base to the bottom, which now turns that exponent to a positive. And then I can reduce 2 to the 4th, which 2 times 2 times 2 times 2 makes 16. So the answer is 1 over 16. Do not say the answer is negative 8. Do not say the answer is negative 16. Okay, it's 1 over 16. All right. So here this is saying if the negative exponent is in the bottom, you could bring it to the top. Okay, so let's take a look. Oh, looks like we have another example. And this is just what I was talking about. So I have 1 over y to the negative 3. If you were asked to write this expression without any negative exponents, well, you need to change the position. You need to bring it up. So you bring the y up with the 1, so it becomes 1y to the positive 3. But you don't need the 1. There's a hidden 1 in front, so you just don't write it. You want to write it as reduced as possible. So the answer is just y to the third power. Okay, so let's look at a couple other ones. All right, so I'm going to go ahead and simplify each expression using only positive exponents. So I have a negative exponent here that does not make your answer negative. Okay, there's a negative in front, then sure, that's just negative. You don't worry about that. What we're talking about specifically are negative exponents, not negative bases, not negative numbers, but negative exponents. So I'm going to bring it down. So I bring it down. So now I have two levels. I have a top and a bottom. Okay. and that exponent becomes positive. And if there's nothing on top, you just put a 1 there as a placeholder, okay? Because you could always put a 1 in as a placeholder for anything, because 1 times or 1 divided by any number is just itself, okay? Same thing here. We have a negative exponent. Oh, sorry. I went ahead and simplified 5 times 5 times 5. I got 125. If you're unsure about what it simplifies to, just put it in Desmos. Okay, it's really easy. So this one here, I'm going to change its position. I'm going to bring it up. So it's 1 times 3 to the 4th, which is just 3 to the 4th. Okay, and remember that my exponent has become positive once I change the position. And then 3 to the 4th is 3 times 3 times 3 times 3, which is 81. If you don't know what it is, put it in Desmos. Okay, I'm not giving you big numbers. You should be able to get these on your own anyways. So here, let's say we're doing a problem and we end up with something like this, or just, hey, simplify with only positive exponents. What I'm going to do is I'm going to change the position of only the base that has the negative exponent. That's not going to change. This one has a positive exponent. It's okay where it's at. So I bring it down. Notice how that exponent became positive. What do we put on top if there's nothing on top? What's our placeholder? There's a 1. And we end up with 1 over x to the 5th y cubed. Okay? So how do we use this? Okay, actually, we have to try this. So take about a minute or two and just see if you can reposition these so that there's only positive exponents. Okay? All these bases are different, so we're not combining anything, just repositioning. All right, so I'm going to bring the A down. I'm going to bring the B up, but I'm going to put the letters in order. So I'm not going to make it C and then the B on this side. I'm going to put the B in front because the A is now down here. So I end up with this positive B squared and this positive 4 on the A. All right, no biggie. Okay, so how do we use this rule? Well, let's suppose we're doing a division problem, right? We have bases, same bases with exponents, and we're dividing. So just to keep things easy, what I do is I write them separated. So I keep the bases the same together. Notice how they're separated. And then I know what's what. So I'm going to go ahead and keep the base and subtract the exponents. So I have a to the 3 minus 16. And then I have b to the 5 minus 4. So right now, when I combine them, when I bring them together with this rule, those bases are on the top. And what we do is we let the exponent tell us whether it stays on top or if it goes to the bottom. Okay, because if the exponent becomes negative, then we're going to bring it to the bottom. But if it stays positive, then we're going to keep it where it's at. That's important right there. So 3 minus 16 is negative 13. 5 minus 4 is 1. I shall bring that down. Okay, reciprocate it, bring it down. Notice how when it's down, it becomes a positive 13. I still have that b to the first, which I'm just going to write as b. So technically, I don't need this 1 because the b is on top. It's still there. So I'm just going to write it as b over a to the 13th. Okay. So here's another example. All right, let's say we're dividing this. So I'm going to go ahead and separate them. So I'm going to keep the base and subtract. This one's kind of hard because it's negative 3 and then minus negative 1. So you got to be careful there. And then remember, if they're the same and you're dividing them, if they're the same, just cancel them out. I don't have to worry about that y now because I know it's going to be 7 minus 7, which is 0, and anything to the 0 power is 1. Okay, so let's do a little side work. So I got negative 3 minus negative 1. So if you remember, you add a line, change the sign. So negative 3 plus 1 becomes negative 2. Okay, or you could have used Desmos. So if I plug this into Desmos, this is what I get. I get negative 2. I get the same result. So I end up with x to the negative 2, which it says simplify using only positive exponents. So that's not a positive exponent. So we'll use the rule in regards to negative exponents, and we'll bring it down. And we get 1 over x squared. Notice how it became, that exponent became positive. All right, so pause it, take 2 or 3 minutes and try this one. Okay, don't just wait for me or keep it going and just copy exactly as I do. Remember, we're taking we're taking notes, and we're doing it in a positive way. We're doing it the way we should by trying the examples. Okay, so I'm going to separate first. Separate first. Okay, remember, if you haven't done it, you need to pause the video. Right, active note taking. So I'm going to keep the base, subtract the exponents. There's a hidden 1 right there. Keep the base, subtract the exponents, negative 3 minus 2. And then keep the base and subtract the exponents, z minus negative 4. Okay, so a lot of stuff going on here. I know maybe what you wanted to do right away was move things around. I mean, you could do that, but it just makes it more confusing in the end. Okay, so remember, these are all now on top. These are now bases in the numerator. We let the exponent decide whether it stays or goes. Okay, so we've got 1 minus 2, which is negative 1. We could always use Desmos if we need to. Negative 3 minus 2 is going to give me negative 5. And then you would add a line, change the sign, which would give you plus 4, which gives you 6. Okay, so it looks like the x and the y have negative exponents, which are going to reposition them underneath the z to the 6. Okay, so we don't really need those 1s because that z to the 6 is actually there. I mean, I know it looks like it's in the middle here, but that's just the way the math type creates it. It puts it there. It technically is a top. Okay, so the z to the 6 is on top, and then we don't need the 1 on the exponent of the x because it's implied, and then y to the 5th. Okay, so hopefully you guys were able to get that. Okay, but that's kind of as challenging as it would be. It's a really, really good problem. So if you did get it right, smack yourself on the back. Give yourself a nice pat on the back because you're golden. And stay golden, pony boy. All right. So let me stop this.